Following 3 years of careful planning, preparation and technical development, an international team of scientists and engineers departed Southampton at the end of May aboard the RRS James Cook on a research expedition to the North Sea. Led by the National Oceanography Centre, the aim was to test sensors designed to detect escaping carbon dioxide in the unlikely event of a leak from a sub-seabed storage site. The site chosen for this experiment was close to Shell's GoldenEye platform, 100 kilometres off Scotland's east coast. Here, the team rendezvoused with project partners from the German research organisation Geomar aboard the research vessel Poseidon. The first stage was to use a specially commissioned drill rig built by Cellular Robotics, lowered 120 metres to the seabed, to push a curved pipe into the sediment with its outlet 3 metres below the seabed surface. Next, the bespoke carbon dioxide and trace gas cylinders in their cradle were lowered over the side in a very delicate operation. They contained 3 tonnes of gas, which was to be pumped through the seabed pipe over 11 days, to test whether an array of sensors could detect the deliberate release within the sediment, at the seabed surface, and in the water column above. The cylinders were connected via hoses to the inlet on the pipe, using a work-class ISIS remotely operated vehicle, demonstrating the skill of the ROV pilots. Sensors were positioned around the area where the gas was expected to bubble through the seabed. These included optodes, acoustic detectors and a range of other platforms carrying sensors to detect the chemical signature of the carbon dioxide and the traces that gave it a distinct chemical fingerprint. The gas was turned on, and to a collective sense of relief and jubilation, the gas began to emerge through the sediment. Quite an achievement. More sensors were positioned to sample the gas, and even to film the bubble stream, with an optical array to capture how the gas behaves as it leaves the seabed. Gas samples were collected for later analysis, as it left the sediment, and within the water column. The local residents, an eel, an octopus and a Norway lobster, seemed more curious than concerned. Nearby, sediment cores were also taken for further investigation into how carbon dioxide reacts within the sand and mud. Back at the surface, a Gavia autonomous underwater vehicle armed with sensors was launched to take further readings in the vicinity of the release site. With the work completed and declared a great success, the ROV dived again to uncouple the gas supplies and retrieve the equipment from the seabed. The Strategies for Environmental Monitoring of Marine Carbon Capture and Storage STEMM CCS experiment has shown for the first time in a real open water situation at depth that we now have the sensors that can detect even small releases of carbon dioxide. This should increase confidence that if a leak occurs, however unlikely, we now have the technology to find it and monitor its progress and effects.